Okay, so the recording button is now on. Again, welcome and a very good evening to all of you, students of here. We have students of 5 Arcade, a few from Baituri and Citrin. Okay, so this is our lesson on 3.2 resistance, the second content standard in chapter 3. So we have finished with the first one, current and potential difference. So I hope everybody now are clear about current and potential difference. Okay, the first important things you must understand in the first learning standard 3.1 is to know what is the meaning of current, okay, to know what is the meaning of potential difference, and also to understand the electric field, okay, how to draw electric field pattern where they are directed from, okay, into the negative and out from the positive charges. Okay, and we also have discussed what is the effect of an object which is placed in an electric field. We have discussed two examples last time. The candle which is placed in between an electric field, you can see that the flame of the candle disperse into two sides in ununiformly, okay, because of the mass of the charges of the electron and proton. Another example, we have seen the motion of a ping pong ball which oscillates continuously in between the electric field. Okay, so that is what we have discussed in 3.1, current and potential difference. So for those who missed that classes, you can watch the video recorded for that session, which I have shared to you the link. Okay, for 5 Baiduri last time who went for the ujian lisan bahasa Cina and miss the classes conducted in school. Okay, later I will share you also the link for the recorded video on 3.1. I conduct with 5 Akid and 5 Citrin. Okay, so you don't have to worry about that. Okay, students, are you ready and good to go with resistance? So I think without further ado, let us begin our lesson for this evening with 3.2 resistance. Okay, talking about resistance, there are 6 learning standards in this chapter. It's quite long, but nothing very much difficult. Okay, as long as you can give your fully focus. So I believe you can do well with this content standard 3.2. Okay, so for tonight, we are going to discuss the first two learning standard 3.2.1 is to compare and contrast what is ohmic and non-ohmic conductor. And second is to solve problem involving combination of series and parallel circuit. Okay, if I'm not mistaken, you have learned this in Form 2, right? Series and parallel circuit. Am I right? Do you remember? Yeah, you have learned this in Form 2, right? Because most of the physics syllabus we study in Form 5, most of them have been covered in lower form, okay? Transformer, parallel and series circuits and a few more. Okay, so you should have the basic understanding on what is parallel and series circuit. So for the others, 3.2.3, 3.2.5, 2.4 until 3.2.6. We will continue later in school. All right. So the first part in this chapter, the first learning standard is to compare and contrast ohmic and non-ohmic conductor. Okay, student, have you ever heard Ohm's law? Pernah dengar Ohm's law? Okay, when you learn series and parallel circuit in Form 2, I believe you also learn about Ohm's law. Betul? Anybody remember what Ohm's law is? What Ohm's law stated? Okay, you can share your response by opening your mic, or if you feel shy, you can type your opinion or your thoughts in this in call messages. Gradient of VI graph. The gradient of VI graph refers to what, Nicholas? The gradient represent what for the VI graph? Yeah, the gradient represent resistance. So actually in this chapter, we are going to relate current, potential difference, and resistance of as well. So these three resistance, current, and potential difference, they are related in this law, which is called Ohm's law. Okay, so in your module on the very first page on the box, on the top left of this module on page 1, you can write the definition. What is meant by Ohm's law? What is stated by Ohm's law? Okay, boleh tulis sekarang It is referred to the electric current. I is the symbol for current flowing through a conductor is directly proportional to the potential difference across it if the temperature and any other physical condition are kept constant. So this is what mentioned in Ohm's law. Okay. Again, it says that the electric current flowing through a conductor is directly proportional to the potential difference across the conductor if the temperature and any other physical conditions are kept constant. Okay, later we will see what are those other physical condition which it refers to. Okay. So if they ask you in the exam states Ohm's law, so this is what you should write. It is quite long, but I hope you understand how to write it. When you understand, you will memorize it automatically. Okay. Don't memorize blankly. The most important, you know what is relate in Ohm's law. So it relates electric current and potential difference. Okay. You know what is current and potential different, right? We learned it before in 3.1. All right. So are you done with Ohm's law? And this is the formula for Ohm's law. Okay, V equal IR. You may write this formula as well. What is V? V is stated for potential difference, and I is the current, R is the resistance. So from this formula, if you look at this three-type triangle, it relates what are the relationship between each of them. So V equal to IR, all right? And if you make I as a subject, so I become V over R. Okay, and you make the resistance as the subject. Resistance is potential difference divided current. Okay, so this is the triangle you can use to understand Ohm's law. V equal IR. V, I repeat, equal to IR, and then I equal to V divided by R. R is V divided by I. Okay. So this is Ohm's law formula against V equal IR. Okay. Next. Okay, so to understand this subject involving electricity, this is the symbol for all the devices which you have to know very well. Okay, ammeter. What is the purpose of ammeter, students? Ammeter is used for what? To measure
current.
Yeah, to measure current. Very good. And this is the symbol for ammeter. If you are asked to draw a circuit diagram, so this is how we draw ammeter. Okay, and this is the symbol for voltmeter. Voltmeter is used to measure what?
Voltage.
Yeah, voltage or potential difference. And this is the connecting wire. This is the symbol for resistance, battery or dry cells. And this is the symbol for switch, constantan wire, and any kind of wire. And this is the symbol for bulb and rheostat. Okay. Can you, do you able to draw the circuit diagram last time I asked in the ujian pengesanan? Boleh lukis tak circuit diagram itu? I come up with one question, ask you to draw the circuit diagram. Can you draw them?
Sikit-sikit.
Okay lah, nanti kita tengok correct drawing owner. So for example, this is how we connect a wire with a dry cell, and this is X, ini voltmeter, ini another one battery connected to an ammeter, and this is resistor X. X ini sebenarnya apa? Ini conductor lah. Okay, it can be a wire or any conductor. And if you look at this drawing, this is how we connect ammeter and voltmeter in an electrical circuit. Okay, from this drawing, how we connect voltmeter to a conductor, student, or this one can be any electrical appliances. It can be a bulb, it can be an iron, it can be a kettle. So X ini can be any electrical appliances. So how we connect voltmeter to conductor? By series of parallel from this drawing. Parallel. Okay, very good. So remember, voltmeter should be connected in parallel to the electrical appliances. Meanwhile, for ammeter, it is connected in series with the conductor or any electrical appliances. So this is the basic understanding you must have, the basic knowledge on how to connect voltmeter and ammeter. Yes.
What is the rheostat? Rheostat.
Rheostat itu adjustable resistor.
Oh.
Adjustable. Resistor has a fixed value, for example, 10 ohm, 1 ohm. For this rheostat, it can be adjustable. Okay, the value can be adjustable. It can be increases or it can be decreases. Depend on certain situation. Okay. All right. Okay, so this is experiment to show the relationship between V, I, and R in Ohm's law. Okay, this one also you can find in your module. Okay, we have figure A and figure B shows two electrical circuit. The question is, why do ammeter shows different readings? Why do the bulbs light up with different intensities? So this is our first experiment to understand the relationship between V, I, and R. Okay, can you spot the difference between figure A and figure B, students? Apa perbezaan dia?
The bulb is brighter in B.
Yeah, the first difference you can see the brightness of the bulb. Okay, the bulb in figure B is brighter. Okay, the bulb in figure A is dimmer. Okay, another difference you can see.
The ammeter
Actually,
reading.
there are three. Yeah, there are three difference you can see there. The first one is the brightness of the bulb. The second difference.
The ammeter reading.
The ammeter reading, very good. You can see the ammeter reading in figure A lower or higher?
Figure A is lower.
Figure A is lower, yes, very good. And figure B, the ammeter reading is higher. Okay, another one, the third difference. The third difference you can see.
Of the battery.
Yeah, very good. On the number of dry cell. In figure A, we have single dry cell. In figure B, we use two dry cell. Okay, very good. Okay, so what inference we can write for this situation? Any idea? Inference. Remember, do you remember how to write an inference?
Forgot.
Okay, Nicholas said the more dry cell, the brighter. Okay, so actually for the inference, you can write current influence, okay, the brightness of the bulb. Okay, current influence the brightness of the bulb, which later on the current is actually due to the number of dry cell, which means refer to the voltage supply. So this is our inference, current influence the brightness of the bulb. And when we come to the hypothesis, this is the things that we can test in a laboratory. So the higher the potential difference, the higher the current. So this is the two variables related in this study. Okay, the higher the potential difference mean the number of batteries. Okay, the higher the current supply, mean the higher the current, later you will see the bulb will be brighter. Okay, so you can write the inference and hypothesis first. If you are done, you can type done so you can go to the next slide. Okay, Wei Xiang, welcome. We've just started about 10 minutes. Okay. Okay. So again, the inference, the current influence the brightness of the bulb, and for the hypothesis, the higher the potential difference, the higher the current. Or you can say when the potential difference increases, the current increases. All right. Okay, students, next, this is the aim of this experiment. Okay. So it come out in a not correct way. So the aim is to study, okay, to study or to investigate the relationship between current and potential difference. And this is our variable. Manipulated is the current, and our responding variable is potential difference, and the fixed variable is length of conductor. Okay. Actually, for manipulated and responding, it can be the other way around. Okay, in some experiment, we make the potential different as the manipulated variable by using a different number of battery, and we are using a fixed resistor. But in this experiment, since we are making the current as a manipulated variable, which means we are using adjustable resistor, which is rheostat, and later you will see the voltage reading will be different. Okay, where it will determine the amount of current flow in the circuit. So this is the fixed variable, length of conductor, diameter of wire, and
Teacher,
temperature. All right.
can I
Yeah.
write the fixed variable as the same number of bar?
Same number of bar. The number of
The
same
number
number of
is
bar.
same.
Where is our? So in this study, we are not using a bulb. Kalau you tengok dalam apparatus and material, the bulb is replaced with constantan
Okay.
wire. Okay. We are not, if you look at this circuit diagram, we are not using any bulb there, but we are using constantan wire as our conductor. Okay, so we are using switch, dry cell of 1.5 volt, mean we are using single dry cell, 1.5 volt, ammeter, this is the voltmeter, and an adjustable resistor, rheostat. The purpose of a rheostat here is to adjust the amount of current flow in the circuit. All right. Constantan wire is the type of wire. We have copper wire, we have silver wire, we have constantan wire, we have steel wire. So normally we are using constantan wire in an experiment. It's the type, okay, the name of the wire, constantan. Okay. And SWG ini determine the diameter of the wire. SWG, standard wire gauge. So this one 24, we have 28, we have 32, 36, okay. SWG ini determine the cross-sectional area or the diameter of the wire used.
Teacher,
Okay,
standard wire
students.
what?
Okay. Standard wire gauge, SWG. Standard wire gauge. Okay, it determines the cross-sectional area of the wire. Yeah, so we have 24, 22, we have 26, 28, 32. And the bigger the number is, the smaller the diameter. Okay. So the bigger the number, the smaller the diameter or the cross-sectional area of the wire. Nanti cikgu akan tunjuk ada satu slide. Standard wire gauge. Standard, W is for wire, G is for gauge, G-A-U-G-E. Alright. Okay, students, and this is the information about ohmic conductor. Okay, ohmic conductor. Constantan wire is one example of ohmic conductor. Okay, so what is ohmic conductor? It's a conductor which obeys Ohm's law. Remember just now Ohm's law, it said that current is directly proportional to potential difference. Okay, so constantan wire is one example of ohmic conductor which obeys Ohm's law. Okay, so this is how we do the procedure. When you close the switch mean you close the switch, so the switch is on. So the circuit is complete and the current will flow in the circuit. So you can see there will be a reading in the voltmeter and ammeter as well. So we adjust the rheostat until the ammeter reads the current of 0.2 ampere. And after that, you record the voltmeter reading, and this ratio we can calculate by using calculation. Okay, using a formula, we can find the ratio. Okay, then we repeat the experiment by adjusting the rheostat to make the current flow at 0.3 ampere, 0.4, 0.6, and 0.5 and 0.6. So for each of this value, you will find a different value of the voltmeter. Okay, then from here we can calculate what is the ratio. Okay, this is example of reading you are going to get. When the current is 0.1, the voltage reading 0.16. When the current increase 0.2, the voltage also increases to 0.26. So from here you can see the pattern. When current increases from 0.1 to 0.5, the reading of the voltmeter also increases from 0.16 to 0.62. Okay. So the ratio you can calculate using a calculator. V divide I. Okay, you can check lah either this value correct or not. So you can fill up your table first with all this value for I, V, and its ratio, right? Okay, if you have any question along the discussion, you may ask. Don't feel hesitate to ask, or you can write. Just write in the in-call messages. I will read and respond to them. Okay. So are you done with the value, students? Okay, so for this ohmic conductor, if you see from the Ohm's law, we say directly proportional, right? So it shows here when the current increases, the reading of the voltmeter also increases. Okay, so can we go to the next slide for non-ohmic conductor? Okay, for non-ohmic conductor student, filament bulb is one example of non-ohmic conductor. Non-ohmic conductor means it does not obey Ohm's law, which means when we are using this filament bulb in an experiment, when you plot the graph later on, you won't get a graph of directly proportional relating V and I. Okay, later we will see what is the pattern of the graph for non-ohmic conductor when we plot a graph of V against I. Okay, so in this second procedure, we replace the constantan wire with the filament bulb. Again, constantan wire is an ohmic conductor. So then we repeat the same process again. Close the switch, adjust the rheostat until the reading reads 0.14 ampere. Okay, then we record the reading of the voltmeter and we repeat the experiment with a different value of current by adjusting the rheostat all the time. So later in school, I will show to you how is this rheostat looks like. Okay, we try to build a simple electric circuit so you know how the rheostat function and how to get a reading from voltmeter and ammeter. Okay, after tomorrow holiday on Wednesday, Thursday, and Friday. All right. Okay, students, and this is the reading obtained from this filament. But example of reading you can get. Okay, the current 0.2, this is the voltmeter reading 1.4, and when the current is 0.4, you can see the voltmeter reading is 4. Okay, so we go back first to the ratio for the first experiment. Okay, for this, this is the ratio. You get 1.6, 1.3, 1.27, 1.25, 1.24. So the ratio is quite consistent except for the first reading. Okay, 1.3, 1.27, 1. It is not far from one and another except for the first reading. Okay, but for here, if you look at the pattern of the increases of the voltmeter reading and current. Okay, welcome Sebastian. Okay, so this is the ratio that we get. Okay, the first ratio is 7 from the first reading, V over I. The second is 8, and then third is 9, and the fourth reading 10.3, and the fifth reading is 10. So you can see that the ratio, the reading for the ratio is increases. Okay, it does not consistent as the ratio shown by the ohmic conductor. Okay, so this is the difference between ohmic and non-ohmic conductor. So later when we plot the graph for these two experiments, okay, so this is how you can compare them. Okay, in your module, the graph is readily on page 4 and page 5. So later you can try to plot according to the reading shows in the table. Okay. So I show to you the example of pattern of graph first for ohmic and non-ohmic conductor. Okay, so we plot V against I. V is our voltage and I is our current. Okay. So you can see the difference. Oh, sorry, it was too fast. Okay, can you see the difference between these two patterns, students? This is the pattern for graph for ohmic conductor, which is the constantan wire. And this is the pattern we obtain from the non-ohmic conductor, which is the filament bulb. Okay, what is the difference you can see between these two graphs?
One is straight and the other one is curved.
Okay, so this one we can say the relationship is, yeah, that, yeah, very good. For this one, it is a straight line started from the origin. Okay, so we can say V is directly proportional to I. But for this one, non-ohmic conductor, can we say V directly proportional to I? Sorry, above here is V and not R. Here, can we say it is directly proportional?
Cannot.
Cannot. Okay, this one, the label is wrong, supposed to be V, not R. Okay, cannot because it is a curved graph. Okay, so what can you say about the relationship between V and I here in the second graph, students?
Inversely.
Inversely? Are you sure? How y increases with x. Okay, the relationship y increases with x. You only can say the voltage here increases with the current. The potential difference increases when the current increases. For this one, you can say, the first one, you can say the potential difference is directly proportional to the current. Kalau inversely proportional graph dia macam mana? Sinway, this is not inversely proportional. Inversely proportional, the graph will be curve this way, the gradient is negative. Ini inversely proportional. Okay. This one not inversely proportional, but V increases with I. Alright. Okay. Okay, students, so what can we learn from these two graphs? Okay, so you can write the relationship. Okay, this one you can write in your module on page 2, number 3, the conclusion. Okay, the conclusion. Second, you have to plot the graph. Later, you can plot. Okay, in another time, tomorrow you are free, right? So you can plot the graph later. So you write the conclusion first, number 3 in page 2. For experiment A, from this pattern, we can say current is directly proportional to potential difference, or you can write potential difference is directly proportional to the current. Meanwhile, for experiment B, the non-ohmic conductor, you can say the larger the current, the larger the potential difference. Or when the current increases, potential difference increases. Okay, for this one, I prefer you to write current directly proportional. You write the potential difference also. Can first, okay? You better if you write potential difference first. Potential difference is directly proportional to the current. All right. But nothing wrong if you write this way, but I prefer you write potential difference directly proportional to current. It shows that when the current higher, potential difference also higher. Okay. And for the discussion, are you done with the conclusion? Okay, remember from the pattern, you know this is we learn in Form 4, ini pattern for directly proportional, V directly proportional to I, and this is the pattern showing that V, sorry again, this is V, not R. Okay, so V increases as current increases. Okay. Okay, now this is the precaution you can write for this experiment. Okay, can you guess what is the precaution we can take when handling electrical experiments, student? Any idea? Okay, precaution ini you can add lah. You can add any empty spaces in your module. Okay, there are some precaution we can take when handling an electrical experiment. Tapi tolong jangan tulis don't conduct the experiment with wet hand. There is no such precaution in physics. Memanglah betul you tak boleh jalankan dengan tangan yang basah. But technically we didn't write in that way. So normally this is the 3 precaution you can write when you are dealing with electrical experiment. The first one, make sure the connecting wire are connected tightly. Okay, they are connected tightly, no loose connection. Second, you can say avoid parallax error when taking the reading of the ammeter and the voltmeter by make sure that the pointer and the image of the pointer in the mirror are overlapped. Okay, mean you can see, you must read exactly from the top of the pointer, not from the other side, because it may show a shadow when you look from the left or when you look from the right side. Okay, so we look exactly from top of the pointer to prevent the shadow or overlap of the needle. deflection needle. Or you can say turn off the switch if not taking any reading so that the temperature of the constantan wire remain constant. So this is very important because when we want to prove Ohm's law, we must make sure the temperature of the wire used is always in constant. Okay, so if you keep turn on the switch even though you're not taking reading, so this will build heat inside the wire. So when it builds heat, definitely the temperature will be increases. So it will give effect to the result of your experiment. So you won't get an accurate results then. Okay, and this is the discussion we can write. The first one as shown in your module. What is the function of rheostat in the circuit, student? So rheostat to adjust or to control the flow of current in the circuit. Okay, this is the function of a rheostat, to control the flow of current or to adjust the amount of current in a circuit. Okay.
Teacher, if I write the act as a resistor in the circuit, okay.
Rheostat is a resistor.
Oh.
Rheostat is a resistor. So if you write that way, I'm afraid you are not answering the
Okay.
question. Okay. So what is the function of resistor? Sama lah, resistor itu rheostat. If they ask you what is the function of a resistor, also to control the flow of current in the circuit. Right?
Yes.
Okay, then, yeah, any other question? Okay, we can go to the second one. Okay, the second question. What is the physics quantity? Okay, the second question. What is the physics quantity represent from the gradient of the graph, student? What is the physics quantity represent by the gradient? Before that, you have to calculate the gradient. Okay, from my graph shows here, can you help me to find the value for the gradient? How to find gradient, students, from this graph?
V
So,
divided by.
yeah, V divided by I. So you can take any 2 points along this line. So example here, okay, it takes the fifth point, this point number 1, number 2, number 3, number 4, number 5. Okay, it took the fifth point, which is 0.062 here, divide by the current 0.5. Okay, and here it used the origin. Okay, it used the origin, but you can take any other point along this graph. Kalau nak senang, ambil satu point, then towards the origin lah 0, 0. Okay, so from here the gradient is 0.124 volt per ampere. So what is this value refers to? So this answer question number 3. So the gradient represent the resistance. All right. Okay, so and the next question, what is an ohmic conductor? So this is the answer for number 4. Ohmic conductor is a conductor which obeys Ohm's law. So you write that for number 4. Ohmic conductor is a conductor which obeys Ohm's law. For example, constantan wire. And for number 5, what is non-ohmic conductor? So it is the opposite way. Conductor which does not obey Ohm's law. That's it. Okay, for ohmic and non-ohmic conductor. Answer for number 4 and answer for number 6. Number 4 and number 5, ohmic and non-ohmic conductor. And for question C, they ask you to sketch the graph for V against I to show ohmic conductor and non-ohmic. So from the 2 pattern of graph I show you just now, you can sketch. This is the pattern for ohmic conductor. V directly proportional to I. Okay, so you can draw the pattern now. You can sketch. Okay, this one we call as a sketch. Okay, kalau drawing mesti ada correct scale and values. Okay, so this one we just sketch the pattern showing the axis for V on y-axis and current at the x-axis, and this is a straight line from the origin. And this is how we sketch. Okay, how we sketch. Another one itu dia punya unit. Ini voltage. Depan itu voltage, the quantity or potential difference. Behind itu is the unit. The unit is in volt. Okay. For this one, I itu is the symbol for current, Ampere itu is the unit. Okay, bukan 2V. So the first one is the quantity, behind is the unit. Sinway, are you clear now? Ini potential difference, the unit is volt. This is current, symbol for current is I, the unit is ampere. Alright, and this is for non-ohmic conductor. It is a curve showing that potential difference increases as current increases. Okay, and for the shape, this is you can write for the shape. The shape for the ohmic conductor, straight line through origin. Okay, you write for the shape of the graph, straight line through origin. Meanwhile, for the non-ohmic conductor, on the table, you write the shape, curve shape. Okay, the shape of the graph is curve shape. And this is the relationship between V and I on the table. Okay, so for ohmic conductor, you can write current is directly proportional to potential difference, or potential difference is directly proportional to current. Meanwhile, for non-ohmic conductor, this is the relationship you can write. When current increases, potential difference increases. Okay. And then next for the gradient, you can see the gradient, this has a fixed gradient. Okay, since it is a straight line, so the gradient when you calculate at any point, it will give you a uniform value, a fixed gradient. Okay, showing that the resistance of the wire is fixed. Yes, potential difference is another name is voltage. Okay. Another name for potential difference is voltage and the unit is volt. Okay. So V ini potential difference or volt, V ini potential difference or voltage and V ini is the unit volt. Okay, I hope you're clear now, Sinway. Okay, and this is for non-ohmic conductor student. For the gradient, you can write the gradient. What happened to the gradient, student? From the first point to the last point of this graph, you can see that the gradient is increases. Gradient increases, showing that the resistance of the bulb increases. Okay, it's not uniform, but it is increases. The resistance increases. Okay. So I hope you can differentiate these two graphs for ohmic and non-ohmic conductor from the shape, from the relationship between the current and potential difference, the value of the gradient which represent the value of the resistance. I repeat, for ohmic conductor, the resistance is uniform, okay, or fixed. Meanwhile, for non-ohmic, the resistance is increases. All right. Okay. So can we move to the next part? Okay, so from here we can come, before we come with the conclusion, okay, why for non-ohmic conductor, the resistance increases? So it is explained in this page, which is actually you can find in your textbook. So if you read from this statement, this is, when I show you this graph, so you must understand now, this is the graph refers to non-ohmic conductor. Okay, where V increases with I and the resistance is increases as well. So kalau you baca di sini, the graph on the right show the relationship between potential difference and current for a tungsten filament bulb. Okay, the bulb filament uses a tungsten coil. Okay, tungsten itu is the name of the material. So the tungsten wire is actually an ohmic conductor. Okay, but as the current flow through the coil increases, the temperature of the coil increases and the bulb lights up. Okay, and at the same time, the resistance of the coil also increases with temperature. So under this condition where temperature cannot be kept constant, that's why the tungsten coil in the bulb exhibits or acting as a non-ohmic characteristic. Okay, so this one you can observe in a light bulb. Kalau you tengok lampu kan, semakin lama dia semakin panas, betul. The longer you light up the bulb, so the hotter it becomes. It means it increases the temperature inside the wire. So that's why the wire turn and become a non-ohmic conductor. Okay, but in school, when we are conducting experiment using constantan wire, we try to keep constant the temperature. Okay, so that's why it obeys Ohm's law. But for filament bulb, it cannot be controlled because it must be generate heat, okay, when you operate the bulb for longer time. So that's why it is acting as a non-ohmic conductor. Okay, so students, for this experiment, we come to the conclusion for resistance. Okay, what is the meaning of resistance, student? You know resistance is determined from the gradient. So in words, what is resistance? Anyone?
1 volt of the potential difference will causes the 1 ampere of the current flow in one conductor.
Okay, very good. Good try. Any other answer? Resistance. What do you understand? What is this resistance refers to? Okay, can you get any idea from this picture here? Gradient of VI graph. Okay. So resistance we can write in words as ratio. Okay, so from the formula of R equal V over I, the gradient. So we can write in words, resistance is ratio. Okay, ratio of potential difference across the conductor to the current flowing in the conductor. So this is what meant by resistance in words. Okay, ratio of potential difference across the conductor to the current flows through the conductor. Okay, so this is the formula, resistance or ratio. Okay, potential difference across the conductor to the current flow. Okay, so the unit is voltage per ampere, or normally we call as ohm. Okay, so this is the SI unit for resistance, ohm, OHM, and this is the symbol. It uses symbol of omega. Okay, this is symbol of omega, but we read it as ohm, right? So R V over I. So if you translate this into words, so this become ratio of potential difference across conductor to the current flow in the conductor. Okay. And what is the equation for Ohm's law? Students have to write equation for Ohm's law. So Ohm's law, V equal IR. Okay, where V is potential difference, I is the current, and R is the resistance. Okay, so this is the first part, the first learning standard to understand what is ohmic conductor and what is non-ohmic conductor and what is meant by Ohm's law. Okay, so we understand Ohm's law states that potential difference is directly proportional to the current flows in the conductor, provided that the temperature and any other physical condition are kept constant. Boleh ingat tak? Boleh faham tak? Lagi penting, boleh faham. Okay, so are you doing good so far? You can give some response if you can follow me. Puistan, Eric, we have Nicholas, Chun Yao, Chun Chuan. Okay, are you doing good there? Chun Chuan, Puising, Jia Yi, Jing Xiang, Sun Xiang, Zixuan, Jin Pei. We have Sebastian, Yi Ting, Shamel, Xin Wei, Zetian, and Wei Shen. Okay, ingat saja, senang saja Ohm's law. Current directly proportional to potential difference, provided that temperature and any other physical conditions are kept constant. Okay, and the graph for ohmic conductor is directly proportional, while the graph for non-ohmic conductor shows a curve showing that V increases as I increases. Example of ohmic conductor, can you give one example of ohmic conductor, students? One example of ohmic conductor, yes, very good, constantan wire. And one example of non-ohmic conductor, which is filament, filament bulb. Okay, ya. Bukan ligament, ligament tu lain lah. Itu ligament sini, join between bones and muscle. Okay, filament, it's filament bulb. Okay, not ligament. Okay, students. So now let us continue with our second learning standard. So we have done with our module page 1 and page 2. Okay, the first learning standard. Okay, now to solve problem involving combination of series and parallel circuit. So you can get ready with your calculator because we have a lot to calculate here. Okay. So are you familiar with this circuit? Okay, this one you can find in your textbook. On the left is example of series circuit. On the right is example of parallel circuit. Okay, for series, all the conductor are connected in one line, one path. Okay, one single line. That is called series. Okay. Meanwhile, for parallel, if you see, we have three resistors there. R1, R2, and 3. This one we have R1, R2, and 2. So all connected in one path. So series. For this one, you can see there is a junction parallel. Okay, junction. So they are arranged. This is the first junction where R1 lies at. This is the second junction where R2 is at. And this is the third junction where R3 is at. So series, one path, one single path. Parallel consists of a few junction. Okay. The least junction is 2, minimum 2 junction, and maximum no limit. All right. Okay, parallel. So you can see there's either current flow in parallel circuit and series. Okay, this is how the current flow in series. It flow in one way. And for parallel, the current, once it enter the junction, so it will be divided into 3 junction. If you have 5 junction, mean the current will be divided into 5 and so on. Okay, and this is how the resistors R1, R2, and R3, and this is the reading of the voltmeter. So you can see the voltmeter connected in parallel to our conductor or our load. Okay, and our ammeter connected in series. Okay, this one also ammeter connected in series with our conductor, but the voltmeter all connected in parallel with each conductor. Okay, so how to find current, potential difference, and resistance in both circuits, student? Okay, for series circuit, this is how to find the current flow in the circuit. I ini is the total current. Okay, total current is equal to the current flow in the first resistor, equal to the current flow in the second resistor, and equal to the current flow in the third resistor. If you put kettle here, kettle 1, kettle 2, kettle 3, so the current flow in all 3 kettle are all the same. Or if you put an iron, first iron, second iron, third iron, so the number of current flow in all iron is the same. If you put what else? You put hair dryer here. So the current flow in the first, second, and the third hair dryer is all the same. Okay. Meanwhile, for parallel, how to find the current flow in the circuit? I is the total current. So this is the total current. Since it is divided into 3, you bayangkanlah dia ada 3 anak. Okay, ada 3 anak. So kena bagi sama rata untuk semua anak. Okay, so the total number of current accepted by all the 3 kids will be equal to the total current. So I equal to I1 plus I2 plus I3. So here from 1 divided into 3, and then it will meet back at the end of the junction, combine back, become 1. So this is how we understand parallel circuit. Ini it sames all the way. Okay, I all the way. This one from the main current divided into 3. Finally, they reach back at the end of the junction, combine back, become 1. Okay, current. Second, how to find the voltage or potential difference in the circuit. For series, V is V1 plus V2 plus V3. Okay, this one, let's say the reading is 1. Here the reading is 2. Here the reading is 3. So the total is 6. Okay, for series. V ini plus. V1 plus V2 plus V3. Okay, but for parallel circuit, it is opposite. All V are the same. For example, if the voltage supply is 1.5 volt, so here will be 1.5 volt, here also 1.5 volt, and at the third also 1.5 volt. Sama for parallel. Okay. And for the resistance, effective resistance means the total resistance in the circuit, R will be the resistance in the first conductor plus the resistance in the second conductor plus the resistance in the third conductor for R. Okay. And for parallel circuit, this is how we find the effective resistance. Reciprocal of R equal to reciprocal of R1 plus reciprocal. Reciprocal itu 1 over R lah, kita panggil dia reciprocal in mathematics, plus reciprocal of R3. Okay, so ini formula. Ini formula kena ingat. Okay, how to find current, how to find potential difference and effective resistance in series, and this how to find current, voltage and effective resistance for parallel circuit. So you can fill up first the table in page 3 showing series and parallel circuit and their current, potential difference and effective resistance as well. Okay, are you done with this, students? Okay, so we try to do a few simple example. Okay, first, before we try to find the effective resistance, okay, this is an example shown in your textbook on page 104. Boleh ambil buku teks kalau ada berdekatan. If you go to page 104, okay, this is the first example show 3 resistor. Okay, you can see this is R1, this is R2, this is R3. Arrange in series and parallel. Okay, if you understand this circuit, R2 and R3 are connected in, students, R2 and R3 are connected in parallel and they are in series with R1. Okay, so these two parallel and then in series with R1. Okay, and given the resistance for each is 2, 4 and 12. So they are not identical. Okay, they are all have different resistance. R1 is 2 ohm, R2 is 4 ohm, and R3 is 12 ohm respectively. Okay, when the switch is closed, switch closed means the switch is connected. Switch closed means you close this so it is connected, mean the switch is on. So on mean the circuit is completed, current flow in the circuit. Okay, so find the effective resistance and find the current flow through the 2 ohm resistor and the potential difference across it. C, find the current flow through 4 and 12 resistor and potential difference across them respectively. Okay, kita cuba soalan ini dulu before we go to the example of question in your module. Okay, again, this is our circuit. So you can simplify the circuit first. You boleh ringkaskan dulu circuit ini. Okay, so this is R1, ini R2 and R3, we can combine them. Okay, so when you combine them, dia jadi R4. R2 combined with R3 become R4. So this is, we draw a new drawing after we combine R2 and R3. Okay, how to find the total resistance here in R2 and R3? Okay, so ini R4, macam mana how to find the value? So since they are parallel, so this is how to find the total resistance here. So 1 over R4. Now they are both represented by R4. Okay, 1 over R4 equal to 1 over R2 plus 1 over R3. So this is the value for R4 given 4. And this is for R3 which is 12 volts. So you plus them mathematically. So 4 over 12. Okay. So this, remember this is 1 over R4. So to find R4 we substitute them. So 12 divided by 4, you terbalikkan saja. So which mean R4 ini is 3 ohm, inverted, yes. So R4 is 3 ohm. Okay, so in this we have 3 ohm. Okay, so now we can find the effective resistance. So 2 ohm is now in series with R4 which is 3 ohm, which mean the effective resistance in this circuit is 5 ohm. Senang saja. Okay, can you follow me for this example A, students? So we have to settle the parallel connection first to find the total resistance or the effective resistance in the circuit. You settle the parallel first, then only you add with the series which is R1. Okay, so kita nak cari apa lagi? B, the total current flow in the circuit. So use the Ohm's law formula. Okay, in order to find the potential difference across the R1 resistor, you must find first the total current flow in the circuit. So how to find current? I equal to V divided by R. Okay, V ini 6. 6 ini supply by the battery, 6 volt. Potential difference supply by the power supply. And R ini calculated earlier, the effective resistance which is 5 ohms. So will give you current of 1.2 ampere. So if you read in this ammeter, this is the ammeter in the main circuit, it read 1.2 ampere. Okay. So how to find the potential difference across R1? So again, we use the formula for Ohm's law. V equal IR. So the current flow in resistor R1 is 1.2 ampere and it has a resistance of 2 ohm. So which means the voltage here is 2.5 volt. Okay, 2.5 volt. Okay, and we do the same thing for 4 ohm and 2 and R3. Find the potential difference in each. Okay, so this is how to find the potential difference. Okay, so this is parallel, right? Okay, so this is the total potential difference. Okay, which is ini V, total potential difference. V1 plus V2. Okay, V2 ini apa? V2 ini this one lah, R2 and R3. Total is 6. Okay, total we have 6. And R1 you have 2.4, which means for these two, the voltage is 3.6. 3.6. And since they are parallel, so which means V2 is 3.6, V3 also 3.6 volt. Okay, so are you clear how to find potential difference for R2 and R3, which is in parallel? Okay, so now we can find the current flow in R2 and R3 against using Ohm's law formula. I2, current flow in the second resistor, V2 is the potential difference, and R2 is the resistor. So 3.6 is the voltage here divided by the resistor 4, so 0.9 ampere of current flow here. Okay, and this one 0.3 ampere. So when you total this back, 0.9 plus 0.3, you will get back the total current 1.2 ampere. So here 1.2 ampere entering this junction, 0.9 ampere flows to R2, 0.3 ampere flows to R3, and when they join back here, we get back 1.2 ampere flow to the main circuit. Okay, 1.2 ampere flows to R1, and when here divided into two junctions. Okay, 0.9 entering here, 0.3 entering R3, combine back here become back 1.2 ampere. Okay. If the question is non-ohmic resistor, we can say cannot. Okay, so normally for series and parallel circuit, we apply Ohm's law formula. Mean we consider them as an ohmic conductor. Okay. So you don't have to worry any problem involving series and parallel. We always refer to it as a ohmic conductor. Okay, ini second example lah. You can read from your textbook. Okay, this is the second circuit. So we have two resistors here connected in series, 4 ohm and 4 ohm, and we have 2 and 2 ohm here connected in series, and they are parallel with this 4 ohm resistor. Okay, so we have combination. These are parallel and then in series with these two 4 ohm resistor. So find effective resistance, find the current flow through the ammeter, find the potential difference. So we solve, every time we solve the parallel pair first. So yang ini you tengok A. So we find first this one, 2 plus 2 is 4. So we have 4 and 4 in parallel. Okay, 4 and 4 in parallel. So if you find the total here will be 2. Okay, so 2 plus 4 later will give you 10. So the total effective resistance in this circuit is 10 ohm. Okay, sini 10 ohm. Ini simplify, and then this is the last circuit you can get. So the total effective resistance is 10 ohm. Okay, so we answering question A. Okay, and how to find the current flow in the ammeter? Okay, so this is how to find the current flow. Again, using Ohm's law. V, ini is the voltage supply, 5 volt, and the total resistance we just calculated earlier, 10. So the current flow in the main circuit is 0.5 ampere. Okay, and to find potential difference across point A and B. Mana point A and B? Okay, this one. So to find the potential difference, it is shown in C. Okay, potential difference in IB is the current flow in this junction multiply with the resistance in this junction, which is 2. Okay, so we'll give you 1 volt. Okay, 1 volt flow at this junction. Okay, so ini example dalam buku teks, nanti you boleh tengok semula. Okay, now I want you to try this, the exercises in the module. Okay, this one, the first 2 question, very simple. Student, find the effective resistance for A. Okay, for A, what is the effective resistance? Okay, first, what kind of circuit is this shown in A?
Series.
Yeah, very good, series. Ini tambah sajalah series. So 10 plus 20 plus 10 plus 5, R1 plus R2 plus R3 give you 35. Okay, how about B? B, what kind of circuit is there?
Parallel.
Parallel. Okay, how to find? Sebastian 1.25. Oh, very fast. So parallel macam mana kira? So reciprocal of R1 plus reciprocal of R2 plus reciprocal of R3. So you dapat berapa? Yes, 1.25. Very good. Okay. Now, how about C? Okay, try C. Okay, we have, ini kita panggil apa? What kind of circuit is this for C?
The combination.
Yeah, this is combination circuit. Combine 2 series and then we have here 8 ohm resistor in parallel. Okay, how to find effective resistance here?
Find the parallel first.
So you settle this parallel first. Okay, so this one, if you are familiar with the equation, since they both have equal value, 8, 8. So can you tell me what is the total resistor here?
A.
8, 8. So
4.
8, 8 will be 4. Okay, will be half. If both 4, if here is 4, 4, mean it will be 2. So kalau sini adam 6, 6 means it will be 3. It will be easier if they give you the identical resistor here. So you divide it with 2 only. So you akan dapat. Okay, so for this one, this is the reciprocal for these two, 1 over 8 plus 1 over 8, 2a. So this will give you 4, as I mentioned. So to find the total, which is R1 plus R2 plus RP. So 10 plus 20 plus 4. So we'll give you, yes, 34. Very good, Sebastian. Okay, how about D? Again, we have combination. The first junction, 8 ohm and 8 ohm are in series. Second junction, we have single 8 ohm. The third junction, we have 4 ohm and 4 ohm in series. Okay, so you add these two first, become 16, and you add down here, become 8. So now we have 16, 8, and 8 in parallel. Okay, this one, 16, 8, and 8 in parallel. So you can find the effective resistance. It will be 3.2 ohm. Betul tak 3.2 ohm? Did you get the same answer with me?
Yes.
Okay. Okay, how about E? How about E? E you can find on page 6 in your module, started from question D. Okay, question E, students. Okay, calculate together. Okay, I hope everyone is doing this. Try to practice how to find total effective resistance for series, parallel, or combination circuit. So we have 1 ohm resistor here, and we have 4 ohm and 2 ohm in parallel, and they are in series with 1 ohm resistor. Okay, so your answer for E is
2.33333.
berapa? Okay, Wei-Shen got 2.333. The rest of you, what do you get? Okay, dapat berapa? Okay, so we check for the answer for E. So we solve this one first. 1 over 4 plus 1 over 2, it give you 3 over 4. So which is 4 over 3, 1.33. So here is 1.33. So 1.33 plus 1, so will give you 2.33333 ohm. Okay, senang saja. Apa yang sokong tu declare? Si sokong siapa? Okay, the PRU is coming soon. Okay, F. Okay, F, how to look this circuit? What kind of circuit we have here in F? We have 2 point X and Y. In between, we have 2 ohm, 5 ohm, 3 ohm, and 10 ohm resistor, which are connected in
Series?
Yeah, series. Ini satu saja, one way only, one path. So they are in series. So you just add 2 plus 5 plus 3 plus 10. So it will give you 20 ohm. Ini senang saja. Okay. How about G? G again, we have combination. Okay, so mana yang boleh settle dulu? Which one you can settle first?
The lower part of the
The-
parallel, which is 3 and 9.
Yeah, 3 and 9 you settle first. 3 and 9 you plus first. So down here will become 12. Okay, so and then 12 will be parallel with this 4 ohm. So then you settle them. Then only you plus with these 2 ohm in series. Okay. Okay, what is the answer for G, student?
5.
Okay, 5. How about the rest of you? What do you get? Zetian, you can try eating. Shamel. Okay. So this one we check for G. Okay, this is the parallel 1 over 4 plus 1 over 12 down there. So this is the reciprocal. Okay, then you plus with these two resistor in series. So yes, they give you 5 ohm. Okay, senang saja kan? Okay, try H. Okay, how to read this circuit? Okay, we have how to read this.
Combination.
Ini combination. We have the first resistor 10 ohm and then this is the first junction 20 ohm up there parallel with this 10 and 10 ohm and then series with this 5. So you have to settle this junction first. So down here 10 plus 10, 20. So 20 above and 20 below are in parallel. Okay.
Divided by 2.
So divided by 2, 20 here, 20 here also mean this junction is 10 ohm. Okay, so 10 plus 10 plus 5 supposed to give you 25. Ya, kalau you sudah mahir tak perlu pakai calculator pun. Tengok saja sudah boleh baca. Okay. Okay, for I. For I. Question I. Okay, question I. Okay, so this one combination 5 and 5 is in series and then they are parallel with this 5 ohm down there. Okay. So you can do the calculation, then you can compare with mine. Okay, what do you get for I, students?
Um, 5.
Okay, is it 5? Okay, you can check. Okay, so ini kita ada 1 over 10, this one total is 10. Okay, then ini 5, so 3 to 10, so total 5.
Sorry.
This time you got wrong. Okay, never mind. Don't be too excited, nanti senang salah. So 10 over 3, don't be too exaggerated. Okay, so but it's a good try. 3.33 ohm. Okay, everyone, do you agree with me for I? It is 3.33 ohm. Okay, yes. Okay, so
Yeah,
last.
calculator is a good thing.
Okay, last question for this part. Okay, how to read
Um,
J circuit?
Series. Parallel with series.
Which one is in series?
The parallel first, the 5.
Okay, so we have the first on top 5 and 5 ini is in series. Okay, and down here this 5 and 15 are in series and they are both parallel. Okay, mean on top you have 10. Okay, 10 ohm, and down at the bottom you have 20 ohm. So these 10 and 20 are in parallel. Okay, sebab junction dia ada di sini. This is the junction. So 5 and 5 ini is in series. So total up there is 10. Below here is 20. So we have 10 and 20 in parallel and then in series with this 8 ohm resistor. So this is how we read a combination circuit. Okay, now find what is the effective resistance in between point X and point Y for question J. Okay, Zetian 9.5 ohm square circuit. Zetian 9.5 ohm. This one for which question? Is it J? Nicholas 14.67. Okay, let us check. Okay, so above we have 10. So reciprocal 1 over 10. Down here we have 20. So this is the reciprocal, then plus 8. So for this junction, the effective resistance is 6.67. So plus 8, so it gives you 14.67 ohm. Very good, Nicholas. Okay, the rest of you dapat tak 14.67, 14.67. Okay. Sinwei, can you do? Jinpei, Sun Xiang, can you get? Xixuan, Qing Xiang, Jia Yi. So I hope from A to J you understand how to find. Sinwei sleep already. Okay, students, kita ada lagi beberapa soalan. Okay, ada yang sudah ngantuk ke? Okay. Can we proceed with question 2? Okay, ini
Yes.
simple. We have simple circuit here. Show 3 resistor R1, R2 and R3 connecting in series with 6 volt battery. So this is the voltage supply by the battery. Okay, find the effective resistance, student. Ini does not need a calculator. Tengok saja. Because series. Okay, find the effective resistance. So it will give you, yes, very good. It will give you 12. 2 plus 4 plus 6, 12. Okay, how about the current? Find the current in the circuit. Find the current read in this ammeter. Okay, so how to find the current? Apa formula nak guna? So you can use Ohm's law. Ohm's law. I equal V over R. Okay, so V 6 volt supply by the power supply, and R is the total resistance in the circuit. So the current flow in the main circuit is 0.5 ampere. In R1 also 0.5 ampere, R.2 also 0.5 ampere, R3 also 0. So in every point in this circuit, 0.5 ampere of current flow. Okay, potential difference across V1, V2, and V3. So for series, if you plus V1 plus V2 plus V3, it will give you 6. Okay, so how to find V1, V2, and V3. Okay, ini nak guna apa? Ada kelas student also di sini, jangan memalukan saya. Everyone know you since when you never sleep in the class. Okay, betul kan? Tak pernah tidur. Alright. Okay, V1, this is how to find. Okay, so we are using Ohm's law. For V1, it is I multiply R1. I is all the same, all 0.5. The difference is in R, so they give you different value of V. Okay, so for V1, it is 1 volt. For V2, it is 2 volt. For V3, it is 3 volt. So when you total this, 1 plus 2 plus 3 will give you back the total voltage supply, which is 6 volt. Okay, 1 plus 2 plus 3.
Teacher,
6. Yes.
is it the one decimal places is compulsory?
Kalau ada one, kita tulislah lebih cantik rather than we write a circle number. Okay. So you leave it as 1 decimal places. Okay. Students, okay, number 3. Okay, kita continue lah number 3. Okay, we have 8 ohm resistor, 12 ohm resistor connected in series. Okay, with 12 volt battery. Okay, what is the potential difference across the 8 ohm resistor and 12 ohm resistor? So this is all a very basic question. So you can familiar yourself to settle this kind of question. I believe if you don't have any problem in this, later you don't have any problem if they give you more complex circuit. Okay, because you must have the basic understanding on how to find effective resistance, voltage, current flow in both series and parallel circuit. Okay, so this is the answer shown. Okay, how to find potential difference. So to find V, you must know first what is I, the current flow in the circuit. Okay, so current flow 0.6 ampere. So we can find V in both resistor. Okay, so this is how to find V in 8 ohm. In the 8, this is the current, so 4.8 volt. And for the 12 ohm resistor, the same formula, so R is 12. So 7.2 volt. So when you plus back together, 4.8 plus 7.2 will give you the total voltage supply by the battery, 12 volt. Atau ini another option lah, you boleh kira juga seperti ini. Okay, but the main solution is the first one, the first method. V equal IR. Okay. Okay, ada lagi soalan? Cikgu ingat sudah habis. Okay, number 4. Boleh lagi ke? Now 9:35. Okay, 9:35.
Boleh.
Kita pergi sikit lagi Okay, 9:35. Okay, number 4. Number 4. Okay, we have 3 resistor. Okay, now they are arranged in series or parallel, student. R1, R2 and R3.
Parallel.
They are in parallel. You can see junction. This is the main way, the first junction entering R1, second junction entering R2, the third junction entering R3. Okay, with the value for each resistor as given. Okay, find potential difference across each resistor. How to find potential difference across each resistor? Okay. Parallel. Ini perlu kira tak? Parallel. Okay. Tak perlu kira, mean if here is 6 volt, all here will be 6 volt, 6 volt, 6 volt. For parallel, all the voltage in each branch are the same with the main voltage supply. Ini tak perlu kira. Okay. V is 6 volt. Why? Parallel arrangement. Okay. Now, find effective resistance of the circuit, the total resistance in the circuit. So this one we use the reciprocal lah. Okay. 1 over R is 1 over R1 plus 1 over R2 plus 1 over R3. So is it 1.1? Can you check? Is it correct? 1.1? 1 over 2 plus 1 over 4 plus 1 over 6 and then find the...
Yeah, Nicholas said yes.
Yes, betul lah, 1.1. Okay, so this one, 1.1 effective resistance. Okay, find the current in the circuit. Okay, students. So we have V, 6 volt. We have R, 1.1, which means we can find the current. Okay, we can find the current. 1.09. Sini you mungkin dapat 1.09. 2 decimal places lebih baik lah kalau you dapat 1.09. Okay, so this is how to find current, 6 volt, and this is the effective resistance, so will give you 5.5 ampere. Okay. Okay, how about the current passing through each resistance, student? So this is the main current flow in the ammeter, 5.5. So later this 5.5 will be divided into 3 branches. Okay, will be divided into these 3 branches. The first branch, second branch, the third branch, and finally 5.5 meet back at the end of the junction. Okay, so this is how current flow in parallel circuit. Okay, so how to know from this 5.5 how much entering the first resistor, how much entering the second resistor, how much entering the third resistor? So we use this equation. I equal VR. Okay, use the value for resistor for each. V semua samalah 6. R1 ini 2, so it will give 3 ampere. So 3 ampere flows in the first branch, 1.5 ampere flow in the second, and 1 ampere flows in the third branch. So when you total back together, you will get 5.5 ampere. Alright. Okay, if we have another 2 question here, ada 2 soalan lagi. Okay. Okay, question 5. Okay, question 5. Another 2 question before we end this session. Can boleh ya? Okay, question 5. Potential difference, 3 volt. Okay, this is the supply voltage 3 volt to a network resistance. Okay, what is the reading of ammeter A? Okay, we want to find the current flow in the main circuit. Okay, so we have combination, 6 and 3 are in parallel, and then they are in series with this 4 ohm resistor. Okay, so to find the current, first and foremost, you must find what? to find the current, you must find what first?
The effective resistance.
Yes, very good. Find the effective resistance in the circuit. So this is how we find the effective resistance. This is for series. Okay, so this is the parallel resistor. Okay, the parallel resistor of 6 and 3 ohm. So the effective resistance is 6 ohm. Okay, is it correct? 6 ohm. And then only we can find the current flow, okay, by using Ohm's law. V, which is 3, multiply the divide with the effective resistance, which is 6. So 0.5 ampere of current flow in the main circuit. Okay. Okay, then B. Okay, I can see Wei Shen is interested in this topic. Dia suka kira-kira kot. Wei Shen. What is the potential difference across the parallel network, student? What is the potential difference across the parallel network? Sini berapa? Potential difference at the parallel network. Berapa? Potential difference across the parallel network.
Bukan sama dengan 3 volt.
Berapa? Sekarang berapa?
1.
Sekarang mana? 1. Kenapa 1? Kenapa sekarang sini tak boleh 3?
Tak tahu.
Sebab ada ini. Ini sudah kacau. Okay? Kalau semuanya parallel, then only you tak perlu kira. Okay, semua 3. Kalau ini tak ada, if this one no, then here will be 3 volt, this one will be 3 volt. Okay, but now since we have combination, so ini bukan lagi 3 volt. So you kena kira macam ini, potential difference across the parallel network. So apa formula dia? IR. Okay, IR. Ini effective resistance here in this branch. 2 ohm. Okay, so which means 1 volt. So here is 1 volt. So 1 volt here, which means in this series berapa volt? Should be, sini should be 2 volt. Okay, so later when you add 1 volt plus 2 volt will give you 3 volt. Okay, combination. So combination you kena tengok. Cannot simply say this is 3 volt because we have another one here connected in series. Alright?
Teacher,
Yes.
so in this combination, the ammeter is same
Ammeter sini, ammeter ini flows in the main current. Kalau you letak satu lagi ammeter di sini, okay, the reading will be different lah. Reading here will be lower than the main current. Okay, if you put another ammeter here, the reading will be different. If I put ammeter here, okay, what will be the reading if I put an ammeter here, student? Kalau cikgu letak satu ammeter di sini, berapa bacaan dia?
Ini mau kilas semua lagi ya.
For this one,
Same.
same with this. Same with the first ammeter. Okay, because this one 0.5 flowing, entering these two branches. Okay, entering these two branches and then meet back at the end of these branches. So ini 0.5 flow through this ammeter. Kalau cikgu letak lagi satu ammeter di sini, okay, what will be this ammeter reading?
Same.
0.5. Okay, 0.5. Dia different di sini saja on the branches because 0.5 ini will be divided into 2. Depend on its resistor. Kalau resistance dia tinggi means small current will be flow through here. Ini resistance lower mean much current, much portion will be flow through here. Kalau dia sama, ini 6, this one also 6, which mean the 0.5 will be divided equally. Okay, 0.25 entering the first one, 0.25 entering the second junction. Okay, then when they meet back here, combine back become 0.5 ampere. So 0.5 flowing through this 4 ohm resistor throughout this circuit. Okay, can you see now?
Teacher,
Yes.
so if I put another ammeter the parallel side, belakang itu saya tak letak ammeter lah. So,
sini, sama lah.
pun sama 0.5.
Depan, mana belakang dia? Nanti cikgu padam dulu semula. Okay, erase. Which one? Place ammeter where? Place ammeter here.
The 6 ohm and 3 ohm.
Sini. I put behind. Sini. This side. Okay, this side sama lah. You letak di sini ke, you letak di depan ke. You put here or you put here.
Sama 0.5.
Bukan 0.5. You letak di sini 0.5. Here, before the branch, 0.5. After the branch, 0.5. But in the branch, it's not 0.5. It depends on the value of the resistance here.
So I need to use the formula V.
Yeah, you need as shown in question C. Okay, find the current flow through the 6 ohm resistor, 6 ohm. So if I put ammeter either at front or behind the 6 ohm resistor, so I can calculate the current flow by this equation. So I equal to VR. This is the voltage in this junction. We calculated earlier in V, and this is the resistance for 6. So from 0.5, so we understand 0.17 will go to the top branch, 0.17. So can you find now the current flow in the lower branch? So how to find?
0.33.
So you tolak sajalah 0.5 minus 0.17. If you don't want to use this formula, you just simply can subtract. Okay, 0.5 minus 0.17, so it will give you 0. Berapa ni? 0.5 tolak 0.17, 0.33. Okay, 0.33 ampere. Okay, cuba you guna formula. Sama tak jawapan dia? I equal VR, V over R. So, 1 over 3. Dapat jawapan sama kan? 0.33. So, once you find the current flow on top, below, you can simply calculate it by subtract. 0.5, the current in the main branch minus the current flow in the first junction. So when they combine back behind here, 0.17 plus 0.33, it become back 0.5. Okay, so you letak satu ammeter sini, dia baca berapa? 0.5. You place ammeter here, so it will reach also 0.5. Okay, understand now the circuit. Okay? Clear, students? Are you still there?
Yeah, crystal clear.
Boleh ya, senang saja kan? Okay.
Yeah, yeah.
Okay, so I think this is our last question for tonight. Takut kamu sudah tired. Okay, we try this. Okay, this is question 6. But in your module, it is written as number 8. Nah, you boleh betulkan lah. Okay, so we have another 3. 6A, 6B, 6-3. All are combination circuit. Okay, so the first one, 8 and 8 are in parallel. So what is the
Then
total?
teacher,
Yeah.
why the switch is on? Is the switch?
Switch ini nanti kita tutup lah dia. Kalau you buka tak ada lah. Okay, nanti kita tutup dia lah on. Dia tak mention kan. So we imagine when we find the reading, the switch ini must be closed. Okay, it must be closed. Then only the circuit is complete, current is flowing. Okay, so if you look through the first one, 8, so we know here is 4. Okay, so 4 plus 8. So this one, the total or the effective resistance is 12. So remember, if you want to find the current flow, the first thing you must find is the total resistance or effective resistance in the circuit. So it will give you 12. So then you can find the current by using Ohm's law equation. So for this one, and the voltage supply is 20, effective resistance is 12, so 1.67. Alright. Okay, for B, okay student, ini semua senang-senang sebab ini pun dia bagi sama. 2 ohm and 2 ohm, which means here we have how many?
1 ohm.
1. Okay, this one we have 1. So 1 plus 8. So the effective resistance here is 9 ohm. Yes, 9 ohm. So now we can find current V divide R. So the voltage supply 4.5 divided by the effective resistance 9. So current flow here is 0.5 ampere. Okay. Tapi dia letak resistor di mana? Tengok yang ini you kena tengok. 0.5 ini apa? Ini main current. Okay, main current supply. So we are not done yet, right? Because where is the emitter placed at in this question? It is placed at
The
branch.
top branch.
So this question B is quite tricky. You must be very careful. So when you get 0.5, this is not the end yet. 0.5 ini kalau you letak emitter di sini. Ini. Okay, 0.5. Or you place the emitter here. Yes, this one 0.5. But now the emitter is placed in this branch. So we have to settle dia. Berapa nak cari sini? So
0.5 divided by 2.
0.5 divided by 2. So you understand our main current flow 0.5. So 0.5 entering this resistor, and then later 0.5 will be divided into these two junctions. Since the resistor is the same, so they will be divided equally. 50% go to the top branch, 50% go to the lower branch. So means 0.5 above, 0.5 below. So you akan dapat 0.25. If place emitter here, it will also read 0.25. Okay.
Okay.
Number 3. Okay, number 3 students. Okay, C. Okay, so you settle this first as usual. Ini sekarang tak sama. So kena kira sikit lah. Okay, 1/6 plus 1/2. Okay. 1/6 plus 1/2. Okay. So this is the effective resistance which is 12. Okay. Ini 8 plus 2.5 plus the junction here will give you 12. So you can find the current. Where is the emitter? Ini pun sama. Okay, 2A, this is not the end of the story yet because 2A ini is the main current flow in the circuit. Kalau cikgu letak emitter di sini. So here is 2.5. But now again, the emitter is placed on the parallel junction on the top branch. So macam mana nak kira? Okay, so you can use this equation. Find first the voltage here. Find the voltage. Ataupun you boleh guna ratio. You can also use ratio. 2 ini divided to these two junction. Ini ratio dia 3 to 1, right? Betul. 6:2 ini the ratio 3 to 1. So macam mana kira? So I1 is 0.5 ampere. Okay, this one. V is the voltage in this junction divided by the resistor here on top. 0.5 ampere. Or as I mentioned, you can use ratio. Pandai kan guna ratio? Do you know how to use ratio? Mathematics. Ini dua sama kan? 2, 2, so 50-50. This one, we have 6. Down here we have 2. So the ratio is 1 to 3. 1, 3, the ratio. So less current flow on top, more current flow below because the resistance is higher. Okay, so answer 0.5 ampere. Okay, kalau cikgu letak emitter di sini, if I place another emitter here, what will it read, student? Dia baca berapa?
1.5.
1.5. Macam mana dapat? You tolak sajalah. 2 minus 0.5. So above 0.5, down here 1.5. Okay, so the ratio is 3, right? 0.5, 1.3. Dia punya ratio 3. 6/2. The ratio is 3. Okay. Kalau cikgu letak sini, another emitter I place here. So it will read?
It will
Anyone?
read 2.
Will read 2 ampere. Very good. Cikgu letak lagi satu emitter di sini. It will read?
Same 2 ampere.
2 ampere. I placed another emitter here in front of the 2.5
Also
resistor.
same.
Yeah, also 2 ampere. Alright. Okay, so kalau cikgu letak di sini before it enter the branch, another emitter here. So what it read?
Also 2
Also 2 ampere. Okay, so I think some of you doing good with this. Mungkin ada yang lain yang perlu lebih master. Maybe you need more exercises to understand it. Don't worry, take your time. Any problem you can always ask me or any other friends. Okay, in the school. Okay. So ada apa-apa nak tanya before we end our session tonight? Okay, ada apa nak tanya? Anything Okay, I think I stop the recording first. So thank you very much for being here. Cikgu tutup dulu recording Okay. Siapa nak tanya boleh tanya. Siapa yang tak ada soalan